For pre-calculus, the graphs of secant and cosecant. Now, let's go ahead and generate the graph of secant. What I've done here is collected all the data using our trig3 document. The ratio that we want to do for secant is the opposite or the reciprocal of cosine. Cosine is adjacent over hypotenuse. So let's go hypotenuse over adjacent. That would be E divided by D. Okay, got all my data. Let's take a look on the graph page what that looks like. All right, interesting. There's supposedly a graph of secant. Let's go see if it's true by graphing it. And it matches up perfectly. So here's a graph of secant, and now I don't like this part right here where it's just kind of like half of one and another half here. If we take a look at the graph of secant on a zoom trig window, we'll take a look at that real quick. Zoom trig window, if I add another graph page, and I try menu, zoom trig, and I graph secant. There's a good graph of secant. Now, for our base graph, it's going to be this part right here and this part right here is the part that we will memorize. Okay? All right, so let's go ahead and get a good base graph on our smartboard document. Okay. Here are the critical values for secant. Oh, went a little bit too far there. There we go. There's our critical values for secant. Okay. Write those down, commit them to memory. And let me go ahead and list what they are. Our critical value, the first one we're going to have is negative pi over 2. That's going to be undefined. For 0, that's going to be 1. For pi over 2, undefined. For pi, that's going to be negative 1. The secant of pi is negative 1. And for 3 pi over 2, it's going to be undefined. So as you can see, we're going to have a lot of asymptotes for secant. So let's put our asymptotes on there first. So we have an asymptote at negative pi over 2, and 3 pi over 2. Now you saw what those look like. At 0, we only have really 2 points, 0, 1, and pi, negative 1. Now, here is the graph of secant. This is what it looks like. Okay, that's what it looks like. And then, if we go back to our document real quick, if I put in its reciprocal function, cosine and secants are related, you can see that when I do cosine, how they're kind of related. That red one's the cosine graph. If I do its reciprocal, you see how you get those parabolas? And can you see that there's an asymptote right here where cosine is 0? Right here and, oops, right here and right here. Okay, and the blue one is what we're going to memorize. Okay, let's go ahead and come back to our smartboard document. Let me list the domain, range, and period for you. The domain of this function is pretty tough. The domain of this function is x cannot equal pi over 2n, where n is odd, just like tangent. The range, weird range this time. How about from negative infinity to negative 1? That's representing this part of the graph. Okay. Union 1 to infinity. And that is representing this part of the graph. And there's your information. Oh, and I forgot one last thing. The period. The period of this function is 2 pi. That's when it starts repeating itself. Okay. Now, let's go ahead and do a graph of cosecant. So if I go back to my data, okay, go back to my data, erase these, okay, and I go back to my original data, and I'm going to change my ratio. Instead of E over D, this time I'm going to go E over C for cosecant. So if I go E divided by C up in my ratio, okay, I'm going to overwrite the data. Let's take a look on the next page what this looks like. Okay, I don't think it, okay, there we go. It's those black dots right there. If I go ahead and change what I had there to cosecant, hopefully it'll match up. What am I doing? Here we go. All right, same kind of parabola action. And again, if I compare it to sine, look what it does. See how they're related? It's kind of flipping them up almost. Looks like there's going to be an asymptote right here, right over here, and right here. Oh, about right there. Okay. So let's go ahead and draw our base graph of cosecant. Find that page. All right, our graph of cosecant. Here's our critical values this time. Same as sine and cosine, isn't it? So we go from 0 to 2 pi. Here's what we have. We're going to have undefined at 0, 1 at pi over 2, undefined at pi, -1 for 3 pi over 2, and undefined at 2 pi. We'll go ahead and put our asymptotes in there. Where our asymptotes are. Okay, pi over 2 is 1, parabola the points up. 3 pi over 2 at -1, parabola the points down. And that's one complete period. All right, let's list the domain. That is pi n, where n is odd. No, where n is an integer, my bad. And the range, same as the other, from -infinity to -1, union 1 to infinity, and the period is 2 pi. So these are our base graphs for secant and cosecant. I'm going to make one more video showing different examples of how to graph this with different transformations. Thanks for listening.